In this video, we'll talk about how to find the horizontal asymptote and oblique asymptote of a rational function. Let's start from the first function in A. Okay, so for this function, we want to find the horizontal asymptote or oblique asymptote. We will look at the degree of the top polynomial and the bottom polynomial. Of course, before that, you want to check if it is in lowest terms. It is in lowest terms, so let's check the degrees. The degree for the top polynomial is 1, right? It's 3x to the 1 plus 5. So the highest degree for the x is 1. The degree for the bottom is also 1. So since the degree of the top is equal to the degree of the bottom, we say this function has a horizontal asymptote because the degree of the top is equal to the degree of the bottom. And the horizontal asymptote is the equation y equals, which is the quotient of the leading terms, or the leading coefficient in this case, it's the same, so which is 3. Right, so we have a horizontal asymptote, which is y equals 3. So since there's a horizontal asymptote, there's no oblique asymptote because they cannot exist at the same time. Now let's look at B here for function h. So first of all, let's check if function h is in lowest terms. Since the top and the bottom are not fully factored, let's factor the top, x minus 3, x cubed minus 8, which is x minus 2. This happened to be a difference of cubes, so we'll use the formula. I'll write down the formula over here actually. So if you have a cubed minus b cubed, the formula is a minus b times a squared plus ab plus b squared. So we'll use this formula. So this is x minus 2 times x squared plus 2x plus 4. Now factor the bottom, just a regular trinomial, so x minus 3, x minus 2, right? All right, so it is not in lowest terms, right? They have a common factor, x minus 2. These two are common factors. Okay, so that means this function has a hole in the graph at x equals to 2. Anyway, the problem is not asking us that. Let's find the horizontal asymptote. Okay, so if we cancel out those two factors, you have on top that and at the bottom that. So of course we have to say we cancel out a factor. That means x equal to 2 is not in the domain, right? That's a hole in the graph. Okay, so we need to compare the degrees of the top polynomial and the bottom polynomial. So the top polynomial here, the degree is 2. Right. The bottom here is 1. Okay, so how do I get the 2? Because the highest x term on the top is of degree 2 and of the bottom is 1. Okay, since the degree on top is 1 more than the degree of the bottom, that means we will have an oblique asymptote. All right, so how do we find the equation of the oblique asymptote? We know it's in the form of y equals mx plus b, because it's a line. We will have to use long division. So inside we will write x squared plus 2x plus 4. On the outside we'll write x minus 3. Okay, we'll do the division. Okay, so since we have 2 terms over here, that means 1, 2, the first term of the quotient will appear here. All right, so first I want to find a term over here so that this term times x will give me x squared. So that's x, right? So x times x is x squared. Oh, keep multiplying. X times negative 3, that's negative 3x. Let's draw a line and subtract, just like how we perform the long division with numbers. Okay, now x squared minus x squared is 0. Over here, 2x minus negative 3x. Here is positive 5x. So it's 2x minus negative 3x. Right. Okay, so now let's drop the next term, plus 4 over here. Okay, now I need to put a term over here so that this term times x will give me 5x. So that will be 5. 5 times x is 5x. Keep multiplying. 5 times negative 3, that's negative 15. And I will draw a line and subtract 5x minus 5x is 0. 4 minus negative 15, that's a positive 19. And this is the quotient. And the 19 is the remainder. That means you can write the original quotient as x plus 5 plus the denominator here is x minus 3. The numerator is 19. So what is the oblique asymptote here? It is the quotient. So it's y equals x plus 5. That's the oblique asymptote. Now let's look at C here. For this function, first we need to check if it is in lowest terms. So let's factor the top and factor the bottom. So to factor the top, I'll do it on the side. 2x squared minus 5x minus 12. I will try to factor real quick. I'll do 3 times 4 here. Cross multiply, that's a 3, that's a 8. I need a negative 5 in the middle. That means this is negative. Okay, so I will factor the top as 2x plus 3 times x minus 4. Now let's factor this bottom. So the bottom is 3x squared minus 11x minus 4. This is more obvious, so it should be a 3 and a 4 here. Okay, so cross multiply. 3 times 4 is 12. 1 times 1 is 1. I need a negative 11. That means this 4 is negative. Okay, so I will factor it as 3x plus 1 times x minus 4. Okay, so we can see this graph does have a hole in it, right? Because you have a common factor in the numerator and in the denominator at x equals to 4. Anyway, the problem is asking us what is the horizontal asymptote or oblique asymptote. So first let's decide, do we have horizontal asymptote or oblique asymptote? What do we compare? We compare the degrees, right? So the degree on top is, you can see the simplified version, it will be 1. And the degree at the bottom is also 1. Since the degree of the top is equal to the degree of the bottom, we will have a horizontal asymptote, right? We won't have an oblique asymptote. And it is equal to the quotient of the leading terms. So it will be 2x over 3x, which is y equals 2 over 3. We have a horizontal asymptote here. That's for C. Now let's look at D. First, let's factor the top. And 6x squared plus 7x minus 5. It looks like we can factor the top. 6, let's do 2 times 3, and 5, let's do 1 times 5 this way. So this is a 10, that's a 3. I need a positive 7 in the middle. That means it's negative 3 here. Trace it back, it's over here. So I will factor the top as 2x minus 1 times 3x plus 5. Okay, so rewrite this 3x plus 5. So we know the domain of this function is x cannot be equal to negative 5 over 3, right? So knowing that x cannot be equal to that value, we can cancel that out. So it's 2x minus 1. So actually, the graph of this function is just a line, 2x minus 1, but with a hole at x equals negative 5 over 3. So actually, I can graph it real quick. So how about the asymptotes? We can say there is a oblique asymptote, which is the line, right? So it's negative 1 here, go up 2 over 1. So it's the graph of this function is just this line, but you have to exclude the point x equals negative 5 over 3. So let's say it's over here. So there's a hole in the graph at negative 5 over 3. Okay, that's D. Now let's look at E, this function. Okay, so first let's factor the numerator and the denominator to see if they're in lowest terms. To factor the top, you can see it as x squared minus 4 squared, right? So here we'll use the difference of 2 squares. So you will use the formula a squared minus b squared equals a plus b times a minus b. So we have x squared plus 4 times x squared minus 4, but wait a second, x squared minus 4 is also the difference of 2 squares, x squared minus 2 squared, right? So I'm going to apply that formula again, so I will rewrite that as x plus 2 times x minus 2. That's the top. The bottom, it's pretty obvious, there's a GCF here. We'll factor out the x, and we have x minus 2. Okay, so over here for this function, it looks like we have x minus 2 in common, so we will exclude x equals 2 in the domain, but that is not a vertical asymptote, right? Instead, there will be a hole at x equal to 2. So x cannot be equal to 2. So this graph basically is the same graph as this function with a hole at x equal to 2. Now, let's compare the degrees. The degree on top, you can see it's x squared times x is 3. So the degree on top is 3. The degree at the bottom, it's 1. Right, it's over here, 1. So that means the degree on top is 2 or more than the degree of the bottom. That means we don't have horizontal asymptote or oblique asymptote. That means our graph will resemble the quotient of the leading coefficient, which is on top the leading coefficient